Not a fan?
Some of them are overdone. It
Oh,
can be used
all of mine are overdone. I assure you. Why do something half-assed? Okay. My name is John Chilton. I work at the Minnesota Supercomputing Institute, and I'm the lead software developer on a project called Galaxy P. So I've spent the last couple months sort of wandering around various conferences and yelling at people about doing proteomics in Galaxy. And I wanted to sort of do something a little bit different for this talk today because I have a captive audience, and I suspect there may be 4 people here who care about sort of configuring complex applications and configuration management, and that's 3 more people than any other room I've ever been in. So I'm excited to do that. Just for some background, some of these ideas are sort of, I sort of see this talk as an extension of a much better talk I gave to the Galaxy admins group, and you can see the slides for them. There's a link to the slides there, and you can find that presentation online somewhere. And I spent a long time just sort of making some simple points in that talk that are kind of obvious, but just to sort of say what those are here. I mean, configuring complex applications is hard. Building on open source frameworks to do this can simplify that task. And Cloud Bionics and CloudMan are a good example of this. And packages that I really use a lot and I'm a big fan of. So just to sort of give you a brief outline of Cloud Bionics to sort of set the tone for the rest of the talk. Cloud Bionics basically, to some degree, is just a bunch of lists of packages and then how to install them and tools to automate that. And these packages can be OS packages, language libraries like R libraries or Python libraries, and then custom install procedures. And these custom install procedures are all implemented in Python. And to do this, the Cloud Bionics makes heavy use of Fabric to sort of build these custom install commands. And Fabric is a deployment tool, and it's really great at sort of recreating identical deployments of multiple machines. I'm sort of making the claim here, though, that it's for really like complex web applications, stuff like Galaxy, different institutions and teams are going to want to build different flavors, different customizations, and Fabric's not well suited to this task. Fabric is not a configuration management tool. And so I think that we can do better in some respects for some of these complex applications. And I think Puppet and Chef are 2 examples of sort of industry leaders that have really broad user bases and can do some of these tasks a little better. And I sort of outline 3 ways in which I think they're better than Fabric for again, not for installing BWA, but for installing something that's really complicated and it doesn't have a sort of direct installation feature or path. That's things that need to be configured, I guess. So one thing is they're higher level. So Fabric is a low-level procedural library, whereas Chef and Puppet are DSLs with higher level constructs for services, dependencies, packages, have concepts of object orientation. They have built-in easy templating and great for configuration files. They're composable. Applications can be broken down into packages that can be easily shared. There's a huge wealth of existing best practices, configurations that you can apply. And they're testable. So great unit testing frameworks are available for both of these. So what I actually did, and not a ton, is extended Cloud Bionics to sort of use Puppet modules and Chef cookbooks. So, as I said, Cloud Bionics just lists of packages. You can now add Puppet modules and Chef cookbooks as package types, or as packages. These will sort of, when you apply Cloud Bionics, these are enabled. These will be bundled up, shipped to the remote server. The underlying Puppet or Chef as needed will be installed, and the configurations will be applied to the server. So, and it integrates pretty well with the existing Cloud Bionics structures for properties and packages. Your Puppet and Chef properties can be set via Fabric, and again, these YAML files are used. So just to outline some initial applications that I've been using this for, as I've been doing Cloud Bionics development, I'll just talk about the 3 I've used briefly, and they're kind of all Galaxy related because everything I do is kind of Galaxy related. One is the LWR, which is a tool I developed to stage and run Galaxy jobs on remote servers without requiring a shared file system. I mean, my goal with the Cloud Bioinformatics integration is, at some point in the future, to sort of allow Galaxy instances to sort of cloud burst into the clouds using CloudMan. We'll see how that goes and if that pans out. If it goes well, I'll be up here again next year talking about that, hopefully. And the Puppet module for the LWR is available and has been integrated into Cloud Bioinformatics. Globus is a set of tools for federated data transfer, identity management, things like this. Ravi Maduri's team at Chicago put together a bunch of chef cookbooks a year and a half ago to sort of make some of the deployment of these things a little bit easier. I forked them and adapted them a little bit for Cloud Bioinformatics, and these have been integrated. There's a link there to instructions for how maybe to use grid FTP to transfer data into an image, a machine image made with Cloud Bioinformatics a little bit faster, hopefully using Globus grid FTP. And finally, BioCloud Central, which is a great Django application developed mostly by Brad Chapman and Ennis, to allow users to sort of easily launch Cloud Bioinformatics and CloudMan instances. Again, I sort of integrated it into Cloud Bioinformatics. This one's a little bit weird, I guess. I mean, well, don't think about it too hard, but kind of recursive. And basically, I'm using it to power biocloudcentral.msi.umn.edu, where so I'm sort of pointing end users at that to sort of launch Galaxy P instances on Amazon. So one of the reviewers for this talk asked me to talk about why you would want to use this stuff in Cloud Bioinformatics. And I guess if you're going to use Cloud Bioinformatics and you have a complex web application, then this is probably a good idea. But if you want to just sort of apply these Puppet modules or these chef cookbooks, Cloud Bioinformatics might potentially be overkill, or there might be better tooling available from Puppet Labs or Oxcode, is it the chef company? Yep. So I love Cloud Bioinformatics, but I'm not going to sort of sit up here and tell you this is the best way to do Puppet or the best way to do Chef. I'm just going to say it's a way to do it. It is broken into, but there is a cool feature here. This is the part I really like, actually. It's kind of a small thing, but it's really fun. So these modules are broken up and integrated as Git submodules. And the upshot of that is each directory that contains these configurations are linked out to other repositories on GitHub. And so you can easily just integrate these modules into your own local institution's repository system the same way, or into other tools such as the Globus provision tool put out by the University of Chicago. Since I originally put these slides together, that I've come to learn that tool is not really actively developed, but so, oh well. But there are a lot of tools like that. Anyway, sort of getting to the point. So, I guess if I could take anything away from this, or if I'm trying to advocate anything, it's to sort of try to build a community around these. Because you probably, maybe you're using Cloud Bioinformatics, maybe you're not. You probably don't care about the particular applications I mentioned, but I think we can all hopefully agree that a repository or a clearinghouse for like high quality interoperable modules for use in any sort of context, be it Cloud Bioinformatics or institutional repositories or anything like this, could potentially be a good resource. And so if you're interested in sort of just trying to do this, I created this GitHub account, this bioconfig account or organization. I don't know. If you're interested and you care about these things, let me know. And if you want to put something there, let me know. And it's a good path to get it integrated into Cloud Bioinformatics, I guess. And with that, I guess I'll end. Any questions? Oh, I should say, I don't want to thank Slide, but thanks to MSI, the NSF, NS, Brad, etc. Galaxy team. All right. Questions?